So continuing from where we left off, the ball is thrown straight up from a cliff at 12.5 meters per second. Ah! What is that 12 point? Well, first of all, read the question. What are they asking me to find? Because we're going to defic. What are they asking me to find? Okay, let's write down D equals question mark. All right, let's figure out what they've told me. What's that 12.5? Someone said acceleration. I got to gently say, I don't think so. What are the units next to it? So can it be an acceleration? If it was an acceleration, what would the units be? Meters per second squared. Okay, so which one? Because there's two velocities in our equations. Which velocity? This is your initial velocity. And it's up, so positive. I see a 6.85. What's the 6.85? Right now, Jordan, I know two things. I don't need to find a third. By the way, it's funny. Did Doug talk to you yesterday?
Yeah, he asked the same question like me.
And I did the same repetitive joke with him too. And I did this. It was just odd that two basketball players. Doug sits right there. Exactly the same question that you asked when I got on your case for being repetitive. Anyways, it's a small world. Hey, I know one more thing. I don't need to tell you this. I won't tell you this. As soon as you're in free fall, you know this. What? What is it? We can add that. See, otherwise we can't solve this without that, because we don't have any equations that can help me find given two things to find the third. But all of the equations, if I know three things, I can find the fourth. Hey, I'm looking for an equation that has d, vi, t, and a in it. Which one?
D equals vi t plus a half a t squared.
And conveniently, D is by itself already, Amanda. I like. This is straight plug and chug. This is going to be D equals VI, 12.5, T, 6.85, plus a half, negative 9.8, T squared, 6.85 squared. Now, before we start crunching numbers, read the question. Is the ball ending up above or below from where I started from? Below. So am I expecting a positive or a negative answer here? If I get a negative answer, I'm going to smile, because it probably means I did it right. So go to your calculator, 12.5 times 6.85. Now that's positive. But then I have a 0.5 times negative 9.8. You know what? We have a positive minus a negative, and hopefully the negative is big enough that we get a negative answer. I hope. And I think 3 sig figs looking at this question, if I want to be fussy. What'd you get? Anyone else? I need a confirmation. By the way, you need to practice this on your calculators. If you're not trying to type this in, if you're going to plan on learning to use your calculator on the test, that's a little silly. Yeah. Where would yours be, oh, pray tell? Boy. Eventually. All right, I've taken care of all the meatheads that didn't bring their calculators. Oh, disappointed with all my students. I'll even put that on the internet. What do we get? Anyone? Is Nate right? Nathan right? What did you get? Anybody else? See, 680 meters seems a little high, because that's almost negative 144. Anybody else? Negative 144. So this is also your chance to figure out where you zigged on your calculator. So try and redo it. You should be able to type this in if you have a good calculator, straight as is. Now, you get a negative answer. I asked how high the cliff is. Callum, technically, how high is a scalar? It's technically 104, but I'm not fussy. If you say negative, that's fine. Okay. Hey, let's try another one. Example 3. A ball is thrown straight up with a velocity of 32 meters per second. A, how long does it take for the ball to reach its maximum height? Okay, what are they asking me to find in part A? Yeah, we're continuing from where we left off last day, sorry. Yep, go ahead. How long does it take for, what's it asking me to find? Time. Let's write down T equals question mark. Elijah, are we in free fall?
Yeah.
Oh, right away we can say A equals negative 9.8. Cool. What else do I know?
Initial velocity.
Oh, initial velocity. VI is what?
32.
32. This is not enough because I only know two things and I'm trying to find a third. I know one more thing. Does anybody see it? Yeah. What's V final at the very, very top for a split second? For a split second at the top? Is it 0 for a split second? Like for a but yeah? Ah. So this is one more thing I can assume. If we're talking about the top, we can do that. So I'm looking for an equation that has T, A, VI, and VF in it. Can you get the T by itself? Can you read it? T equals, yeah, it is VF equals VI plus AT. How would I get the T by itself? So look at the equation. See it, see it, see it? See where the T is? See it, see it? Keep looking at it. I'm going to walk you through it. See it there? Yes, stare it. What else do you see? There's an A. What's the A doing? I'm going to do that later. I'll divide later. What else is on the same side as the T? What else is, you already said that. What else is on the same side as the T? Look, see where the equal sign is? There's something else on this. Ah! What's the VI doing? So how will I move it over? Okay, so I had a VF over on the left already, right? And you said I'm going to subtract that over. Yes, 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 yes. And how would I get the T by itself then? How would I move the A over? What's the A doing? Timesing. So what am I going to do with the A? What's the opposite of timesing by A? I can't hear you. I'm sorry. Divide. Maybe, is that what you said? Sorry. VF minus VI over A. There's our new equation. You can memorize that if you want. Don't. Learn how to rewrite. Now it's plug and chug. It's going to be 0 minus 32 all divided by negative 9.8. Tanisha, time. Is time a scalar or a vector? Let me ask you again. You ready? Is time a scalar or a vector? Ah, very good. I'm glad you picked up on that. So is time going to be negative or positive? Because it doesn't have direction. Time moves forwards. I'm expecting a positive answer. I'm looking at the top. I notice it's negative. Oh, but is the bottom also negative? Woohoo! It's going to be a positive answer. What do you get? 3 point. Give me a few more decimals, and then we'll do the sig figs. Because I think since there's a part B and a part C, we're going to use time later on anyhow. So what do you get exactly? 3 point what? 3.265. What's after the 5?
3.
Okay, so 3.265, and then we would go to 2 sig figs, approximately 3.3 seconds. Yes? Okay. So if you know how fast you're launching something and you're ignoring air resistance, you know how long it takes to get to the top of its arc. This is some of the math they were doing back in World War II with the artillery shells, for example. Although artillery shells, you're also firing at an angle. That's a whole other bag of wax. We're going to get to that in May. B. What's B asking me to find? I don't have a height anywhere on my, what's it asking me to find in terms of what's part of my equations? Use physics speak. Height's not a physics word. It's asking me to find a displacement or a distance. So let's write down D equals question mark. If I had turned the page, Perry, I would redefic. I would relist my data. Do I have all my data listed just right above in the previous? Okay, I'm going to be lazy. I got it all listed there. So I'm looking for an equation that has, well, it has to have D in it. If I can do it with one that has VI, A, and VF, that's great. If I have to use time, I will. But, yeah. Times. Okay, read me the thing again. D equals That's not the first one you read me. You said d equals vi plus a half over 2. Which one are you reading me now? Because you've combined two equations and I'm confused. Okay, that's what because you didn't say the times time, and I just said to you, I'll use time if I have to, but I'd prefer not to because if I got this wrong, then I'm getting this wrong. So I'm okay with that, but I think there is an equation that has d, vi, a, vf, and no t in it. There is. Yeah. Vf squared equals vi squared plus 2ad. Did you hear me say the letter t there? Nope. Hey, Sam, how good are you? Can you get the d by itself? Let's talk you through it. Are you ready? Are you ready? Are you ready? Here we go. So let's write down d equals. Can you get it by itself? Woohoo! Sit up straight with a feeling of confidence and pride. I can rearrange formulas. Except the plural of formulas is formulae. So really I should say, I can rearrange formulae. Because bragging about doing math with bad grammar is counterproductive. Oh, let's plug in chug. V final. Oh, we were able to reason that it was 0 because we know at the top, Elijah, for a split second, things come to a stop. Minus V initial, 32 squared, all over 2 times negative 9.8. Riley, how many numbers are there on the top? It's meant to be obvious. How many numbers are there on the top? Better put the top in brackets. How many numbers are there in the bottom? Better put the bottom in brackets. In other words, if I'm going to go to my calculator, if I'm going to type this in, and I do want you to learn to type stuff in one fell swoop, I'm going to go 0 squared minus, by the way, did I really need to go 0 squared? What is 0 squared? Just plain old? I could have just gone 0, but I'll do the squared so you can see it. Minus 32 squared, close bracket, divided by bracket, 2 times negative 9.8. By the way, the maximum height, am I expecting a positive or a negative answer? If I say the maximum height, are we above or below from where we started from? So if I get a negative answer, I know I've zigged. Huh? Do you get 52.2448, that there? So I'm going to write 52.24. And now I'll go to sig figs. I think we're going 2 sig figs, so 52 meters. C. How long is the ball in the air for? Next to that, you can put a quotation mark. We have a name for this. We call this the time of flight, the flight time. So I may say to you, instead of how long is the ball in the air for, I may say, oh, it's the time of flight. Oh, and I'm pretty sure they're asking me to find a time. Anybody have an idea on how we can solve this? There's 2 ways. One short and one longer but clever. Can we see how I can figure out how long the ball was in the air for? Sorry, who's talking? AJ.
How long it took to reach and how high it went? Like the time of the distance or whatever.
Uh-huh. Do what?
That's part I don't know.
Okay.
You divide the velocity by the
Riley.
Take the distance that it is in the air, and then find out the time that it took to get from the top to the bottom, and then add it to the old time that we found.
Okay. That would get us there. That's way too much work. And maybe there's something so obvious about projectiles that you haven't spotted it. Perry. Perry! What? Oh, you're close. You said times the maximum height by 2. You're on the right track. There is a way to do this timesing something by 2. But not the height. There's a saying, you may have heard it. It goes like this. What goes up must Heard that before? Now, that's a proverb. It's meant to say that people who succeed often come crashing back down. But actually, it's actually not bad physics. If we're ignoring air resistance, you know how long it took to get to the top? We did figure that out, 3.265 seconds. You know how long it takes to get from the top back down to the bottom? 3.265 seconds. So the shortcut is if you know the time of flight. Now, I got to be careful. Sam, this only works if you're starting and ending on the same height, ground to ground. Doesn't work if you're on a cliff. If you throw something up off of a cliff and then you let it land all the way down, it'll take the same amount of time to get back to where you are, but then it's going to keep falling and that's going to take more time. But for now, the easy way, we'll call it method. I can't call it method P for Perry. He wasn't quite right. We'll call it method 1. I was going to name a law after you. Next time. Answer A. Oh, answer A, Mr. Dewick. Come on, brain. Times 2. There's one way to do it. And I would do this if I had already found the time to the top. What is that? And you know what? I'm going to double this is why because I knew this was coming up. Sam, this is why I said, give me a few extra digits. So I'm going to double the 3.265 times 2, and that gives me 6.53. Because if I double the 3.3, I would say 6.6. Actually, it's not. 6.5, isn't it? Yes, yes? So 6.53 or 6.5 seconds. Now, that's method 1. You can draw a little line right here. We're going to come to method 2 in just a second. But method 2, in order to use method 2, I need to know the answer to D. D is saying, what's the impact velocity of the ball just before it hits the ground? And don't say 0. 0 is after it hits the ground and comes to rest. When I say impact velocity, I mean that one. And there's a very easy way to answer this showing no work whatsoever. And you can figure it out by a proverb. The proverb is, what goes up must. Michael.
The initial velocity of the first equation is the impact.
So what do you think the answer is to D?
32 meters per second.
Why is Michael right and wrong? It's not 32.
-32.
What?
-32.
Why negative?
It's going down.
Okay, that's the little tweak we have to make, Zach. We have to say down, negative. But you know what? If we ignore air resistance, whatever you throw up, it comes back down. And when it comes back down, it's coming back down at exactly the same rate as it left. It slows down all the way up. At the very top, how fast is it traveling for a split second?
0.
Then it speeds up, speeds up, speeds up, speeds up. And you know what? When it comes back to your hand, how fast is it going? Exactly what it left. What was it negative? Was it 32? Which lets us go back to part C and look at method 2. If I hadn't done part A already, if they had simply given me the first paragraph, a ball is thrown straight up with a velocity of 32 meters per second, how long is it in the air for? I would go like this. Well, A equals negative 9.8, V initial equals 32, V final equals negative 32, right? Find T. Can't I now use exactly the same method as we used in part A? In part A, we knew V final, V initial, and A. Find T. V final, V initial, and A. Find T. In fact, we can use Tanisha's equation, right? Yours was, it was VF minus VI over A? That's what you said, yeah? Which one's right, Mr. Dewick? They both are. Which one do you use? Whichever one is quickest. If I had done A already, I would have used it to answer C. If I hadn't, why would I want to do math twice if I can do math once? I'm lazy. Try it, though. See if you get the same answer. So you're going to go negative 32 minus 32 divided by negative 9.8. Do you get 6.53? Oh, is this also a way, you finish the test on this unit, you could go back and check an answer, doing it a different way, getting the same answer, and then you know you're right? Yeah. Do you get negative 6.53? Yep. Probably a few more decimals, because we did round this answer off up here. It wasn't 3.265. Stop. It was 3.265 garbage. So do you get exact? Well, do it, Mr. Do it. Negative 64 divided by negative 9.8. Negative 32 plus negative 32 is negative 64. Or, anyways, 6.531. We're close enough. And, by the way, Andrew, for part B, I could have used d equals VIT plus a half AT squared from here using this time, and I would get the same answer. Now, I would avoid it on a test, but if I wanted to check my answer later on the test, I would quickly, and I could probably go d equals VIT plus a half AT squared almost straight on my calculator showing no work. And if I got 52.24, hey, I know A is right. Has to have been, because I got the correct distance without using my answer for A. I got the same answer using my answer for A. I must be right. That's nice. E. What's the displacement of the ball once it hits the ground? Ooh, did somebody say it? I might have heard it. What do you, AJ, impress me. What?
0.
What's the distance the ball traveled? 52.4 on the way up and 52.4 on the way down. The distance it traveled is 104.8. Did I do the math right? It's twice the on the way up. But the displacement which actually gives you a third, slightly yuckier method to solve the question for C. You could have gone like this. Don't write this down. You could have said the displacement is 0. VI is still 32 plus 0.5 times negative 9.8 times t squared. Anybody know what's half of 9.8? Have you guys spotted that yet? Half of 9.8 is 4.9. So you could, I'm just going to quickly show you, you would get this. Negative 4.9 t squared. How many variables are there in that equation? Just one, t. A t squared and a t, which is why that's a yucky equation. It's a quadratic. It takes a bit of practice to solve. I don't use that method, but it would work. Some of you may have solved quadratics already. Oh, why is my answer wrong? Don't forget units. I'll take a half mark on the test for no units. All right. What else can I ask you? Let's see here. A baseball is thrown straight up. It leaves the thrower's hand 1.6 meters above the ground. So now let's be a bit more realistic. When you throw something up, you don't lay on your back on the ground so that your hand is 0 high and then throw. In real life, Zach, you're throwing it from about here. Or if you're throwing it overhand, although if you're throwing straight up, it's much easier to throw underhand. So let's imagine we're throwing it underhand, straight up. Easier throw. And let's imagine it's not Elijah, so we're 1.6 meters above the ground. Okay? How long will it take for the ball to reach the top of its path? What's it asking me to find in part A? What else do we know? What is? What else do we know? Are we in free fall? Yep. By the way, this bugs a lot of kids. How can you have a positive velocity to negative acceleration? It is going up. It's accelerating down. What that really means is on its way up, it's slowing down. Perfectly fine. A little weird, perfectly fine. I need one more thing. What? What's 0? I heard somebody say 0. What's 0? Oh, V final. In fact, this is the same question as part A from last one. Good, solve this. I'll do it quietly up here. I think we can use Tanisha's equation. Oh, 3 sig figs. Oh, no, 2 sig figs. No, I didn't use the 1.6 in this question, did I? So I can go to 3 sig figs so far. Do you get 1.65 seconds? Or am I wrong? Yeah? Okay. What's the maximum height? D equals. What equation can I use to find D? I could use one with T in it. I prefer not to. Which one? If you're not sure, look back at example 3. Oh, we can use the VF squared one? Let's get the D by itself. That was D equals, it was VF squared minus VI squared all over 2A. Yeah. We said 0 minus 16.2 squared, 0 squared, all over 2 times negative 9.8. Zero squared minus 16.2 squared, close bracket, divided by bracket, 2 times negative 9.8. Do you get 13.39? Or if I want to 13.4? Why is that wrong? Because it is. We have not found the maximum height. And this is where we have to take into account that other bit of information that the question gave us.
Well, you have to add 1.6.
Elijah, what?
You have to add the 1.6.
What we've just found is how high the ball is above its launching point, but how high was the launching point above the ground? Eventually, in Physics 12, we'll start doing lots of stuff off of cliffs, because it's a classic question, and you have to take the cliff's height into account. So here's a mini cliff, someone's hand. I think the height is going to be 13.4 plus the 1.6. I think the actual height above the ground is going to be 15 even, yes? And you know what? I should go probably 15. Oh, no. 1.6 is 2 sig. Oh, no, wait a minute. We're adding. For sig figs for adding, you always went to the biggest decimal point. So I'm going to go 15.0 meters. Can you make it, Matt? Ah! Nothing? What's the final velocity of the ball when it reaches its original release point? What? Oh, yeah. Which was what? Negative 16.2 meters per second. Okay. Free fall. We'll do a few more weird free fall examples. There are some strange ones in the actual assignment. So can you all look at the, hello, free fall, where is it, Mr. Duick? I must have it here. Solving acceleration. Ah! Right click. Turn this back on. So far for the homework I have assigned 1, 2, 3, 4, 5, 6, 7. I've skipped 8. Number 9, a lovely graph here. What are we graphing? What versus what? Velocity versus time. Okay, I can deal with that. What do you think this chunk... Come on. What do you think this little chunk right here is? And then we have a long chunk, and then this chunk right here. It says, this is the velocity of a ball thrown straight up by a strong pitcher as a function of time. In the first part of the graph, ending at location A, the ball is accelerated to 39.2 meters per second at a time of 0.2. You know what? That's the throw. That's the throw. Oh, and if you want it to go up, you'd better accelerate it faster than gravity when it leaves your hand. Right here, there's where it's leaving their hand. And do you notice what happens to the velocity when it leaves this pitcher's hand? It gets smaller and smaller and smaller and smaller. And how fast is it traveling right at location B? 0. Where is the ball right then? At the top. Okay, because this is not a distance time graph, it's a velocity time graph. Then why is it getting bigger but negative? Oh, it's coming back down towards me, coming back down towards me. We've given you the key points that you need to do things like slope where necessary, because this is a velocity time graph. The slope is the acceleration. See if you can answer 9A, B, C is good, D is good, E. You know what? I think this whole thing works. I is a bit weird. Okay? The answers are attached right there, so you can work on that. You can hustle back.